Okay, so from Q1 from Boolean simplification, and you have to use clean plus key method. Okay, plus key method, tabular method. I think you can remember this. Okay. Okay. So you no need to use other things. Okay. The Boolean algebra or kernel K-maps you no need to use. Okay. You have to use this clean max plus tabular method to simplify one Boolean expression. Okay. So anyway, you will get all of you will get sum of product. Okay. So it is somewhat easy. Okay. Sum of product expression. Okay. Yeah, sum of product. So it will be normally 4 variable. Okay. 4 variable question. Okay. That means it is like this. Okay. And you will get some product value. For example, 2, 4, 1, 2, 4, 1, 0 like this. Okay. So this kind of expression you will get, and you have to use Queen Max tabular method to simplify. Okay. So I hope you can do this. And also you should know what are the advantage and disadvantage of Queen McCluskey method. Okay. Advantage, disadvantage of Queen McCluskey method. Okay. Tabular method. And also what is the difference between this one and K-map? Likewise, you should have that idea. Okay. And you should be able to solve this kind of sum of product. Okay. With 4 variable using Queen McCluskey tabular method. Okay. So I think it is not much difficult. Okay. So anyway, you will have 4 questions. Okay. 4 questions. Okay. And 3 hours. Okay, 3 hours. That means one question you have 45 minutes. Okay. For one question, you will have 45 minutes. So yeah, this one also you will have 45 minutes. So I will strictly tell you that please use only 45 minutes. Okay. Don't use much for this question. Okay. Use maximum 45. Okay. Maximum 45 minutes to complete this one. Okay. Don't use additional time, because if you haven't got the final answer, you will get the full mark. Okay. Because I could see your procedure is correct. Okay. If I could see your procedure is correct, you will get full marks. Okay. If procedure correct, full marks can be given. Okay. So don't use much time on this question. Okay. Because maybe to get the final value, it may be you have to get more than 45 minutes. Okay. So don't get additional time to complete this one, question 1. Okay. Use only 45 minutes, maximum 45 minutes. Okay. So I will somewhat remind you how to do this kind of one. Okay. So I am not going to completely do this question because time will not be enough. Okay. So I will just give a quick recap of the steps. Okay. So for anything, you have to use your reference book. Okay. So anyway, you can use any software, okay? At the exam, it is open book test, okay? This is open book test. You can use any notes, then any software. You can use AI software, those AI software, chat AI, I don't know, okay? Those things you can use if you want, okay? So any website you can use, any website you can use, also YouTube also you can use, okay? So you can use these any resources available, okay? But you can't share the answer, okay? You can't share the answer. Share the answers in mail or WhatsApp, okay? In mail, WhatsApp, etc. Okay? So you can't, okay? So please keep remember. This is you can't do, okay? This is prohibited. Okay. So any notes you can use, any software, AI software, any YouTube video, anything you can use, but okay. But I recommend to use only reference book, okay? Reference book. This is my recommendation, okay? This is my recommendation, okay? But you can use any resource, okay? Okay, so you can use any resource, but you can't share the answers with WhatsApp or mail or other in social media, okay? So you can use any software, but my recommendation is to use only the reference book. Otherwise, you will get you will waste your time, okay? So all the questions are based on the reference book. So you can use that one. And I think you can answer all the question better. Okay. So maybe using of these things, maybe the additional resources, maybe waste of your time. Okay. So, so that is it. It is up to you. Okay. Anyway, so I will give you a quick recap of question one. Okay. So the question one based on the simplification techniques, okay, Boolean simplification techniques, okay, and you are not asked to use Boolean algebra or K-maps, okay. You have to use the QMC method, tabular method, Queen Max Klasky tabular method, okay, this one, only this one, okay. Uh, okay, so so this is your first question, okay. The first question will based on this Queen Max Clark's tabular method, okay. So you have to simplify that kind of sum of product like this, okay. This kind of sum of product, okay. Um, okay, so so strictly you will be given that kind of uh, expression, okay. F A B C D is equal to maybe 3 2 5 0 like this, okay. So this kind of expression you will be given, okay. So you can see it is 4-bit the 4-bit the 4 variables are there in this expression, okay. So you have to use this value with this 4 variable, okay. So for example, if you write this, okay, so you will get that. So this is the sequence, okay, this is the sequence. So A, B, C, D, okay. So this will be, D will be your least significant bit, and A will be your most significant bit, okay. So you will get this kind of one, 0, 0, 1, 1, okay, this is 3, okay, plus 0, 0, 1, 0, this is 2, plus 0, 1, 0, 1, this is 5, plus 0, 0, 0, 0, this is 0, okay. So you will get this kind of bit stream, okay. Then you have to write this in terms of A, B, C, D variable, okay. So this is a sum of product, sorry, yeah, sum of product. So you have to use the complement for 0 and the true value for 1, okay. So this will be A bar, B bar, C, D, plus A bar, B bar, C, D bar, plus A bar, B, C bar, D, like this, okay. So this will be a Boolean expression. Now you have to simplify this using Queen-McCluskey tabular method. No, D should be the least significant bit, no? It should be the least significant bit. That means it has 0 value. And A has the 2 to the power 3 value, no? So this will be, A will be the most significant bit. D will be least significant bit. Okay. Okay. So I think this is the normal procedure. Okay. This is the normal procedure. Okay. So maybe you can use other way around also. Okay. But I think this is the standard one. Okay. I am familiar with this kind of representation. Anyway, you can represent it other side also. Okay. But if you correctly solve it, you will get the full marks, no problem. Okay. So you can use the other way around. Okay. But I think this is the standard one. Okay. So maybe you better use this standard method because you will face some uh, complete complications. Okay. So I think it is better to this representation. Okay. So anyway, you will have this one. Okay. And you will have another terms, 4 terms. Okay. That is A bar, B bar, C bar, D bar. Okay. So this is your expression. Now you have to use the Queen-McCluskey method, and you have to simplify this. Okay. Okay. So this is your first step. Okay. So what is the second step? You have to group, no? You have to group then according to the ones. Okay. So so these terms have the least number of ones. That means there are no any ones, only zeros are there. Okay. So it will be one group, A bar, B bar, C bar, D bar. It will be one group. Okay. And you will have this representation. Okay. And I think this one has this one and this one has two two ones, okay? So you will have A bar, B bar, C, D, okay? So this will be 0, 0, 1, 1. This will be a single output question, okay? This will be a single output question, okay? Because this also will get much time, okay? So definitely this will be a single output question, okay? So this kind of representation, so here only one output, F, okay? So this is the output actually, F is the output, okay? So if it is the multi-output, you are given this kind of expression. If it is two output, you are given this kind of two output expression, okay? Then you have to solve them. Actually, you can solve them separately and get one question, okay? One answer. And there are other methods also you can use, okay? So for this one, you will get only one output. It will be a single output question, okay? So this will be A bar, B bar, C, D. This has 0 ones. This has 2 ones, okay? And this one also A bar, B bar, C, D. So A bar, A bar, B, C bar, D, okay? So this also has 2 ones, okay? So likewise, you can write the other terms also, okay? So this one has 3 ones, okay? So there is another group that has 3 ones, okay? So this will be a cross product, okay? So what is the next step? Okay, okay. Then you have to do the matching. Okay, I think you can remember. Okay. Yeah, the explanation is there. Yeah, yeah, exactly. Okay. So that is your next one. Okay. So the explanation is there. I'm finding that one. Okay. Okay. So you have done this one. Okay. So this is the third step. No. Okay. So you have to, you have to, you have to check it with the uh, adjacent higher order group, okay? And if there is only uh, one mismatch, okay? So you have to put the dash or cross, okay? I think you can remember this, okay? Cross, and you can write it like this, okay? Then if it is match, okay? So you have to put the tick, okay? So I think you can remember we have done this 2 or 3 questions, okay? So if I'm going to explain this, it will take much time, okay? I think it is not useful, no? Okay. So, so anyway, this part I haven't done actually, okay? Because I get this kind of expression to do the simplification, okay? So, so you will be given the sum of product in this form, okay? So first you have to write it in the uh, so you have to first expand it and write it in 4 variables. Then you have to group it, okay? Then you have to match it, okay? Until the matching is over, okay? So then you have to make that table, Okay, you have to make that table, this one. Okay, this is called prime implicant table. Okay, then using this one, you can get the simplification. Okay, so only actually five steps are there. One is expansion, second is grouping, third is matching. Okay, find the min terms. Okay, fourth is matching. Okay, so you can write it this in two step also. Okay, in one step also. Okay, and the fifth one is after matching completed, you have to write this prime implicant table. Okay, write this prime implicant table. Then finally simplification. Okay, so these 5 or 6 steps are there. Okay, so you have to only follow these things. Okay, so what I want to tell you is that don't recheck this. Okay, if you haven't any mistake, that will be fine. Okay, I'm not going to give you the marks for the final Boolean final expression. Okay, but I am strictly check the procedure and steps. Okay, is that clear? Okay, so please use only 45 minutes to complete this question. Okay, so I think I have uploaded we already we have uploaded 2 or 3 YouTube's video. Okay, so this one. Okay, so I think if you refer this one, uh, you can get the idea. You can get the recap. Okay, so only this one. Okay, so I think now it is better to use the reference book. Okay, because this video is around 2 hours. Okay, so better use to reference book can just remind the steps. Okay, those 5 or 6 steps and do that one. Okay. Okay, so question 2. Okay, that is regarding the question 1. Okay. Okay, so question 2. In question 2, you will get the question related with counters and register. Okay, counters and registers. Okay, so you can use that that one. Okay, so it is based on this chapter, the second question, counters and registers. Okay, uh, so I think you can remember this equation. Okay, so maybe one question is there, you have to use this equation. Okay, for example, if we are using if we are using 5 counters. Okay, and your propagation delay is around 5 milliseconds. Let's say that it is 5 nanoseconds. Okay, so if you multiply this 2 and divided it by 1, okay, so this is a frequency, this you will get the frequency, and that is the maximum frequency of counting. Okay, this is the maximum frequency of counting. Okay, so this is the maximum frequency of the clock pulses given to the circuit. Okay, so maybe you have to calculate, so it is very easy. Okay, so maybe 2 or 3 marks are there. Okay, so you can use this equation and you can get the answer. Okay, then you have to design, you will get this kind of design. Okay, No. So I think we have done one or two design also. Okay. So maybe you are asked to counter that count may be 0 to 6 like this. Okay. So maybe you asked to design. Okay. Design a counter that count 0 to 6. Okay. So exactly this kind of design, one or two design we have done. Okay. Uh, this kind of one. Okay. So this kind of example you will get. Okay. Exactly this kind of question. Okay. So here also you can see that it is counting from 0 to this is um, 1 to 7, no? 0 to 7. Okay. And it is skip the remaining 6 status. Okay. Uh, so that means you have to count up to 0 to 7. Okay. 0 to 7. Okay. But that means this is only count 0 and 1, 1, 1. Okay. So this is only counting 0, 0, 0 and 1, 1, 1. Okay. So these 6 are not counting. Okay. So that is also same, no? So maybe you are given 0 to 6. Okay. Count 0 to 6 or 0 to 5. Okay. So that means you are counting 0, 0, 0, 0, 0, 1. Okay. Like up to 5, 1, 0, 1. Okay. Then 6, 7 you are skipping. Okay. 6, 7 you are skipping. So here you are counting only 2 status, but maybe in this question you are counting 5 yeah 5 status and you are skipping 2 status. Okay. So here you are counting 2 status and skipping 6 status. Okay. Maybe it can be changed. Okay. So this kind of exact design you will get. Okay. Uh, so I think okay, so this is initialization you will not receive. Okay. You will not get. Okay. Only to design this kind of counter. Okay. So I think you can count it. Should I do it? That kind of design. So I think you can refer the this one and you can easily design. Okay. Anyway, uh, should I explain it or shall we go to the other next one? Because we have only I can give you only 2 hours. Okay. So okay. So can someone feedback? Should I do this design or shall we go to the next one? Okay, I hope you can do, and also we have done 2 or 3 design there. Okay. Yeah. So what about others? So I think no need to waste the time, no? for that one. Yeah, maybe this one and this one, maybe lecture 6 and lecture part 2. Okay. This one and this one, I think that design is explaining. Okay. For that designing, you have to first find the status. Okay. Then you can draw the state transition diagram. Okay. Then you can draw the excitation table. Okay. Then you can, using the excitation, from the excitation table, you can just design the counter very easily. Okay, so that is the okay. 11.4, no? Okay, so you have to do, actually you have to no, you are this is open book test, no? So the excitation table will not give, okay, but you can find in the reference book. Okay. So if you know the excitation table for JK or SR, then you can write it for your question. Okay. So in that, this explanation, I have explained how to use them. I think you can remember. Okay. So for example, I will show you. Citation table are there. So in the reference book, excitation tables are available. I think when I am doing the tutorial, I have shown, you know. Maybe. So if you hard to find it in the reference book, okay, so you can easily find it in Google. Okay. Okay. So maybe um, actually the no, you no need to remember the excitation table. Okay. So if you know that function table, you can yeah. So I think you can use the next note. Okay. Actually, if the excitation tables also, you can I think I am explaining, I have explained it. The excitation table is nothing but that functional table, okay? So excitation, the present state and next status are there, okay? But this is also, you can construct this excitation table using just the input and output functions table. Okay, so those are available in the reference book. Okay, so anyway, in the Google also you can find the excitation table easily. Okay, so you can use them. Okay, so I will just explain that how we are skipping. Okay, okay. So for example, let's say that okay, let's say that you are asked to design a counter. You asked to design a counter that can count from 1 to 5 like this. Okay, so you have to count 1 and 5. Okay, so uh, how many bits we have to use this? Okay, we have to use 3 bits, no? So we have to use 3 bits here. Okay, that means 0 0 0 0 0 1 like this. Okay, so you will have 5. Okay, then you will have 6 and you will have 7 like this. Okay, so you are asked to count 1 to 5. Okay, so these are the available status. Okay, and this is status are not there, so we have to skip this status. Okay, so first you have to draw the state space diagram. Okay, so it is very easy. Okay, so you have to start in 0 0 0. Okay, then you have to come to 0 0 1. Okay, then you have to come to 0 1. Sorry, no, we are not using the comma. Okay, 0 0 1. The next state is 0 1 0 2. Okay, so this is 0 1 2. Okay, then 0 1 1. This is 3. Okay, 1 0 0. This is 4. 1 0 1. This is 5. Okay, so you have to come up to this. Okay, then you have to skip that 5 and 6. Okay, 5 and 6 you have to skip. Okay, then after this you have to again come to this one. Okay, so this is your state diagram. Okay, then so these are, so also you can write these things also. Okay, but the available steps are these. Okay, so this is your state transition diagram. Okay, not state. This is state transmission, state transition diagram. Okay, transition diagram. Okay, so you can write this state transition diagram. Okay, so if you know the excitation tables for J, K, or SR flip-flops, okay, then you can develop the excitation table for this transition. Okay, so you have to, so if you consider this one, this will be the past output, this will be the present output, and this will be the next output. Okay, so based on these 3, you can develop the excitation for this transition. Okay, then excitation table is, you can use excitation table as a truth table. Then you can design the circuit easily. Okay, so I hope it is clear now. So only simple theories are there actually. Okay, thank you. Okay, so I think that will be enough. Okay, so anyway, I will show you one transition diagram. No, no, no. You will get the register one. Okay, so So you will get question 2, 1 from these counters, okay, and also from the shift registers, okay, shift registers, okay, but you no need to design a shift register, okay, design is not designing part you will not get, okay, but maybe you have to write the output, okay, if you are given an input, okay, after certain clock pulse you may have to give the output, okay, this kind of question will come, okay, so two parts are there, one related with the count and one related with the register, okay, so I will explain the register one also, okay, before that one, let me show you a state diagram. Sorry, state transmission diagram, okay? Transition diagram. This one, okay. Okay, so these are the flip-flops, okay. So JK flip-flops, okay. So you can see that this state transition diagram for mode 8 counter bits, okay. So all status are there actually, okay. So this is, so this actually this kind of question you will come, okay. Okay, mode 6, that means only 6 numbers you are going to count, okay. So you are going to count 0, 0, 0, 0, 1, sorry, 0, 2, 3, 1, like this, okay. Then again 0, 0, 0, okay. So you have to count this sequence, okay. So this is the uh, counting sequence, okay. This is the counting sequence, plus 0, 0, 0, 0, 1, 0, 0, 1, 1. That means first you count the 0, then you are counting 2, then you are counting 3, then you are counting 1, then you are counting 4, okay. Then you are counting 5, again 0, like this, okay. So this is the state transition diagram for that one, okay. 0, 0, 0, 0, 0, 1, like this, okay. Yeah, so I have given it weight. No, you have to design it with negative edge ticket counters, okay? Yeah, and negative edge ticket flip-flops, okay? Not positive with edge ticket, okay? So I think we have done the positive using the positive edge ticket, okay? But this design you are asked to use negative edge ticket, okay? I think it will not be a problem, okay? The same procedure is there. So the same question I have done in the tutorial, okay? So it will be a same question. Um, so there is no any different, okay? So that is why I given, uh, that is why I asked to use the negative edge triggered flip-flops, okay? So I think it is not much difficult, okay? Uh, Hope you will do it. Okay. Okay, so now, yeah, so this is state transition diagram is for this so this counter will skip these two. Okay, this 3 and this is 5, no? 5 and 7. So it will skip in 5 and 7. It is counting only these numbers. Okay, 0, 0, 0, 0, 0, 0, 1, 0, like this. Okay, so you can see that uh, this is how the bit are transiting. Okay, transiting. Okay, and these are the skip step. Okay, so if you haven't, so these are actually these two we are not using for the design. Okay, so only the available is bit the available sequence are the counting sequence are only considered to make the excitation table. Okay, so this one and this one no need to use for the excitation table. Okay, but you can just mark it in the state transition diagram. Okay, so this kind of state transition diagram you have to design. Okay, then using this one you have to get this kind of excitation table. Okay, so it is not a big one. Okay, it is easy actually. Okay, so that is regarding the counter. Then you have to do one question related with the register also. Okay, I am sorry, I am not sharing the screen. No, sorry. Okay, I'm sorry. Okay, so this kind of state transition diagram you have to do. Okay, so these are the counting sequence. Okay, these are the counting sequence: 0, 0, 0, 0, 2, 3, 1, 4, 6. Okay, so these are the counting sequence, and 5 and 7s are not counting. Okay, so only these counting sequence are used for the excitation table. Okay, this is skipping sequence we are not using for we are not using to construct the excitation table. Okay, so you have to use only these counting sequence. Okay. Mm, so this kind of state transition diagram you have to construct. Okay, for your question. Okay, then you have to use most probably JK flip-flops. Okay, negative edge triggered JK flip-flops you have to use. Okay, so you can construct the excitation table. Then using the excitation table, you can get the circuits. Okay, you can get the circuit. Okay, so 3 counters are there. Okay, for these 3 counters are there. You are asked to design the circuit only. Okay, okay. So I think that is for the counters. Okay, then we will try to do the, yeah. Okay, so the question 2, part 2 will based on the shift registers. Okay, okay. So based on the shift registers. Okay, and so there are 4 types. Okay, maybe you have to remember these things. Okay, Wait. No. Yeah, it is okay. You can actually it is not given. It is not uh, restricted in the question. Okay, so you can use active low negative edge triggered or active high negative edge triggered. You will get the mark. Okay, but it should be negative edge triggered. But you can use active low or active high. Okay, but I think it is better to use active high because that is the normal way, no? Okay, high voltage is represent in 1 and low voltage is represent in 0. Okay, so I just recommend to use active low gates, active high gates. Okay, but you have to use the negative edge triggered flip-flops. Okay. Okay, so there are 4 types of shift registers are there. Okay, so I think I have told you how to draw this kind of timing diagram. Okay, but in the question you are not asked to draw the timing waveform. Okay, so this one also easy. Okay, not much different. Okay, we have done one. We have done this example, I think. Okay, so you are asked to just give the uh, output. Okay, so that means if you are given this kind of registers, okay, so that is very easy actually. Okay, maybe you are given 4 or 3 registers. Okay, these are shift registers. Okay, so this is 4-bit shift register. Okay, so um, initially all have 0 0 0. Okay, so you are asking this kind of pulse. Okay, so normally you are given the serial input and uh, parallel output one. Okay, and you are asking to uh, write the output. Okay, you are asking to write the output for different clock cycle. Okay, so in first clock cycle, what is the output? It is, so let's say that it is initial one. So in the first clock cycle, so let's say that initially it is 0 0 0. So in the first clock cycle, this 1 will shift to this register. Okay, so it will be 1, and this 0 will shift to this one. Okay, so it will be 0, and this 0 will shift to this one. So it is again 0. This is shift to this one, 0. Okay, so at first cycle, you will have 1 0 0 0. This is the output. Okay, so then you may ask to write the so this is for first cycle, maybe second cycle. So this 0 will shift. Okay, so here it will 0, this 1 will shift to here 1, this 0 will shift to here 0, this 0 will shift to here 0. Okay, so you will have the output as at the second clock 0 1 0 0. Okay, likewise you may ask to write the output. Okay, so that is the function of the shift table. Okay, so this shift table can be very easily constructed using XOR. Okay, so the implementation is not much hard. Okay, so I think I am explaining how to construct this kind of shift register using XOR. Okay, so in most actual circuits, okay, this kind of shift registers are made from XOR and flip-flops. Okay, also you need the flip-flops. Okay, these are actually flip-flops. Okay, you can use flip-flops for this bit memory. Okay, then you can use XOR to shift this. Okay, so very easily you can do that. Okay, but the designing part is not will not come to the exam. Okay, so maybe you will ask this kind of um, I couldn't understand your question. Mm, so you are asking about this one, about the register, or fell on to another question. So you asking this question related to the registers. Mm, so I can't understand what is this. This you means these are the input. So these, if we are using SR flip-flops, these are the input. I can't understand this. So, I couldn't get your. Okay. Sorry. Ah, yeah. Actually, the output. Okay. So you are you need to write only Q1, Q1, Q4, only the output. Okay. So you no need to write the input. Okay. You no need to write the input. Okay. So most probably you will ask to write the output. Okay. Okay. So that kind of questions will come to the question two. Okay. And question three, based on the logic families. Okay. Logic families. Okay. So it is third one, fourth, no? This one, based on the fifth factor. Okay. So that is the question three. Logic families. Okay. So I think you can remember that we have different type of logic families. Okay. And this one is most popular one. This one and CMOS families. Okay. This TTL and CMOS families are the most popular one. Okay. And so your question mainly based on this characteristic parameter. Okay. So I think you can remember that. Okay. So these parameters you should know. Okay. What are these parameters? නෑ 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 නෑ. No no no. හරි. එහෙම නෑ. ඒ කියන්නේ shift register එක පොඩ්ඩක් බලන්න. දැන් shift register එකේ ඔය කට්ටියට දීලා තියෙනවා register ගාන. හරි. ඒකේ සාමාන්‍ය question එකේ දීලා ඇති 2 bit, 3 bit, 4 bit ඔය වගේ shift register එකක්. Okay. දැන් හිතන්නකෝ 3 bit එකක් කියලා. එහෙම වුණොත් ඒකේ තියෙන්නේ flip flops 3යි. හරි. flip flops 3යි. ඊළඟට දැන් මේක තමයි flip flops 1 එක, 2 එක, 3 එක. Okay. එතකොට ඔය කට්ටියට දීලා තියෙනවා මොකක් හරි ඉන්පුට් කරන සීක්වෙන්ස් එකක්. එතකොට ඒ සීක්වෙන්ස් එක මේ තුනක් නෙවෙයි. හරි. ඒ සීක්වෙන්ස් එක ඕන ගානක් වෙන්න පුළුවන්. 500ක් හරි වෙන්න පුළුවන් බිට්. හරි. ඊට පස්සේ මෙයාගේ ඉනිෂියල් එකේ මෙයා 0 0 0 තියෙනවා. ෆස්ට් සයිකල් එකේදී ෆස්ට් ක්ලොක් සයිකල් එකේදී මෙන්න මේ 0 shift වෙනවා මේකට. මෙයාට 1ට. හරි. එතකොට මෙයා 0 වෙනවා. මේ 0 මෙතෙන්ට shift වෙනවා. එයා 0 වෙනවා. මේ 0 මෙතෙන්ට shift වෙනවා. මෙයාත් 0 වෙනවා. එතකොට මේක තමයි output එක. හරි. ඕක කීයක් ආවත් එහෙම වෙනවා. ඒ කියන්නේ ඔය කට්ටියට මෙතන bit 4 input bit එක 4 කියලා register 4ක් නෙවෙයි ඒ. හරි. register එකක් වෙන්න පුළුවන්, දෙකක් වෙන්න පුළුවන්, සමහරට 1 bit register එකක් වෙන්නත් පුළුවන්. හරි. shift register කියන්නේ ඒකයි. ඒ කියන්නේ අපිට පුළුවන් මේක තමයි shift register කියන්නේ ඇත්තටම. ඒ කියන්නේ මෙයාගේ bit අපි register එකෙන් register එකට shift කරනවා. කියන්නේ එක රෙජිස්ටර් එක බිට් එක එන්නේ ඊට කලින් තිබ්බ රෙජිස්ටර් එකේ බිට් එකට තමයි shift වෙන්නේ. හරි. නෑ එහෙම නෑ. number of bits, number of flip flops. ඔව් ඒක හරි. ඒ කියන්නේ ඔයාට දුන්නොත් එහෙම 2 bits flip flops එකක් කියලා. Okay. If I gave you it is a 2 bit flip flops, that means 2 bit means that is the output bit. Okay. 2 bit means that is the output bit. Okay. So also you have to care about the SIPO and SISO. This kind of two ones are there. Okay. Shift register. Serial input, parallel output, serial input, serial output. Okay. So if it is a parallel output, the 2 bit means number of flip-flops. That is correct. Okay. If I told you 2 bits is number of flip-flops. Okay. Like this. Okay. 2 bits means number of flip-flops. Okay. That means 2 flip-flops. Okay. So only 2 registers are there. Only 2 registers are there. Okay. So it can store only 2 bits. Okay. So this is the store in bit. Okay. Number of store in bit normally we are giving. Okay. That is how a shift register is named. Okay. So normally if it is a 2-bit register means only 2 bit can store in this register. 3 bit means only 3 bits. Okay. For storing you are using flip-flops actually. Okay. So 2 bits means 2 flip-flops you are using. So if I ask you to, if I say that I am given 2 or 3 input flip-flops, okay, 3 bits 3 bits register, that means 3 flip-flops are there, 1, 2, 3. Okay, is that clear? Okay, so you are asking, so it is, if I tell you it is parallel output, okay, that means this is Q1, let's say that this is first flip-flop output, this is second flip-flop's output, and this is third flip-flop's output. Okay, so this first flip-flop's output, second, third, you will given parallelly. All bits are parallel. So if you are sending 1, 0, 1, 1 like this, okay, so let's say that this is 1. Okay, so here 0, 0, 0. If it is a single input parallel out, serial input parallel output one in the first cycle, clock cycle, so 1 will shift to here, 0 will shift to here, and 0 will shift to here. So it will be 1, 0, 0. Okay, so this is the parallel output. Okay, but if it is serially output, okay, it is output in another way, no? Okay, so this will be 1, 0, 0. Okay, so serial output means so Q3 bits you will first output, Q2 bit second output, Q1 third output. Okay, so serial output means only 1 bit you will get at 1 clock cycle. Okay, so as the output you have to write only 1 bits. Okay, so if I ask you to write the output at first clock cycle, so this will be 1, this will be 0, and this will be 0, but Q3 only will give you the output, no? Okay, so your output will be 0. Next output will be Q2 bit. The late output will be Q1 bit. Okay, is that clear? So you have to care about what is the output procedure, okay, and how many bits are there, and number of clock cycles. Is that clear? ඒක තේරුණාද? දැන් parallel නම් මේ bit තුනම එකපාර දෙන්නේ එළියට. හැබැයි මෙයා serially output කරනවා නම් මේ bit තුනම එකපාර output කරන්නේ නැහැ. output කරන්නේ ඉස්සෙල්ලාම අන්තිමට තියෙන register එකේ bit එක තමයි output කරන්නේ. හරි. එතකොට ඔය කට්ටියට care කරන්න වෙනවා parallel output ද serial output ද කියලා. parallel output එකක් දුන්නොත් මේ මෙන්න මේ Q3 Q2 Q1 වල තියෙන මේක තමයි ඉන්නේ. හරි. හුඟක් වෙලාවට parallel output එකක් දෙයි ඔය කට්ටියට. මොකද parallel input එකක් දුන්නොත් එමේ bit එක එකනේ ලියන්න තියෙන්නේ. හරි. අප මම කියන්නම්. okay 2 bit කීවොත් එමේ එතන තියෙන්නේ flip flops දෙකයි. හරි. ඔය කට්ටියට input එන්න පුළුවන් ඕන bit ගානක්. ඒක කියන්න බෑ. හරි. එතකොට මෙයා first cycle එකේදී මෙයා input එන්නේ, second cycle එකේදී මෙයා, third clock cycle එකේදී මෙයා, fourth clock cycle එකේදී මෙයා, so on. හරි. initial එකේදී මෙයාගේ 0 0 දුන්නා. first clock cycle එකේදී මේක තමයි ඇත්තටම Q1 Q2. ඔකට ලියන්න ඕනේ Q1ටයි Q2ටයි විතරයි. හරි. මෙතන මේ input ලියන්න ඕනේ නැහැ. output එක තමයි හුඟක් වෙලාට අහන්නේ. හරි. So you will ask, so if this is 1, okay, so first in first clock cycle this one shift to here, this register, this 0 shift to this register. Okay, so first clock cycle you will have 1 0. Okay, so okay, so maybe second clock cycle, fifth clock cycle, any clock cycle you can write. Okay, is that clear? Okay, so Q3. Okay, Q3. So you have to mainly know this characteristic. You no need to keep remember because you have the reference book, no? Okay, so you can use the reference book. Okay, so these parameters you should have the understanding of these parameters. Okay, so I have explained them. Okay, I have explained them. Okay, so there are many parameters. Okay, and also you should be able to draw this kind of noise margin graph. Okay, so I have explained it. Okay, so actually for the noise margin you are using so this is output voltage at low level, output voltage at high level. That means this is the output voltage. Okay, so if you consider any logic gates, okay, if you consider any logic gates, if you give a voltage here for 1 or 0, let's say that you are given 5 volt for 1. Okay, so the output may be for 1, okay, maybe less than this 5 or maybe greater than this 5 because these are providing some ACC current. Okay, so these are active device, no? This logic gates. Okay, so the output can be somewhat higher to 5 or somewhat lower to 5. Okay, so there should be a margin. Okay, to understand this this is 1 or 0. Okay, so there should be a voltage margin. Okay, so this is the maximum voltage for low bit. Okay, for example, let's say that if you are telling that the output voltage for low is 2 volt maximum. Okay, so that means if the output is 2 volt, okay, maximum 2 volt or less than 2 volt, so it that voltage is detected as 0. Okay, so for the high voltage it should be a minimum value. For example, it can be a 4 volt maybe. Okay, so if you are given a high if it is a high state, that means once. Okay, so if the output is 4 volt or higher, okay, so it can be understood as a 1. Okay, so for low level you should have a max value, and high level you should have a minimum value. Okay, so between these two, okay, if there is any voltage, so it cannot identify this is 1 or 0. Okay, so that is the normal idea of this noise margin. Okay, so I have explained this using the value also. Okay, so I think it will be okay for you. Okay, so anyway you may be have to draw this kind of noise margin. Okay, so definitely these parameters will be given. Okay, and you have to draw this diagram. Okay, maybe not only to height. Okay, so sometime, for example, I think you can remember that we have designed a counter. No? We have tried to design a counter using logic gates. Okay, but you couldn't get the desired output. Okay, so I told you that maybe one reason maybe. Okay, so this is counter is serial counter. No? Okay, so serial it is connected. All counters are all flip flops are connecting serially. Okay. 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 So maybe the output voltage maybe in this, if it is in this region, this device can't understand it as 1 or 0. Okay. So uh, your design may be wrong. Okay. Sorry. This device can't understand it is 1 or 0, and this input voltage is not enough to this one, so this will not produce output. Okay, so that is here. Okay, so this is the input low voltage, and this is the input high voltage. So it should be a maximum and it should be a minimum. Okay, for example, maybe for one family logic gate should be given at least 2 volt. Okay, two sorry, so maximum 2 volt or less than 2 volt to give the 0, to represent 0. Okay, and maybe 4 volt or higher volt to give 1, to make the status 1, state 1. Okay, so there should be an input low voltage and input high voltage are also there. Okay, so if this input low voltage or input high voltage is not in this minimum or maximum value in this range, okay, so this device can't understand this input. It is he can't understand it 1 or 0. Okay, so this will not give a proper output. Okay, so maybe that kind of problems can be happen. Okay, so you should be able to explain that kind of scenario using this kind of noise margin. Okay, so this is how, in this way you can explain it. Okay, so I have already explained. Okay, if you could understand this, you can explain. Okay, so this kind of question you will come. Okay, and maybe this kind of question also you will come. Okay, so so for example, so there are many parameters. Okay, so you ask to find the average power, average supply current, supply voltage. Okay, so this kind of question also will come, and I think you can do it. Okay, so very easy, that one also. Okay, I think within 2 hours you can complete the paper. Okay, is it okay? So that kind of question you will come. Okay, so so you have to find this kind of parameter. So I will give some parameter like this. Okay, then you have to find these kind of parameters. Okay, so if you can't remember, you can refer the reference book. The equations are there. Okay, so don't try to do this kind of question using that software. Okay, AI software, because you will not correctly direct to the solution. Okay, there are some nonsense actually. Okay, so I'm not recommending you to use that kind of software. Okay, better to use this reference book. Okay, so I think you can do this one. So do you have any problem related with this noise margin and this kind of parameters? So maybe always when you are finding the, I have explained it, okay, average value, okay. So there is always two values related with high status and low status, okay. So if you want to find the average value, you have to add them together and divided it by 2 always, okay. No, that kind of question you will not have, okay. You know it, so we have done it to get the understand, okay. We have done it to get how these are constructing using transistor, diode, and resistor, okay. But that kind of question you will not come to the exam, okay. Uh, so you will come, so the exam question will is strictly based on these characteristic parameters, okay. Is strictly based on these characteristic parameters, okay. So you will have, maybe you are given this kind of scenario, okay. Uh, this kind of uh, uh, you are given maybe some scenario, maybe a scenario, okay, any case, okay, that the circuit is not working or something, okay, then you will ask to explain it using this kind of noise margin and using this uh, parameters, characteristic parameters, okay. Then this kind of you also will have a question to find this kind of parameters, okay. So that is the question you will get, okay. Is that clear? Okay, for the last question, okay, thank you. Okay, for the last question you will get ADC and DAC, okay. So I think the DAC ADC design you will get, okay, design you will get, okay. So complete design you will get, okay. Maybe to you have to design maybe the 8-bit ADC, 8-bit resolution ADC, okay. Maybe the input voltage may be 0 to 5 volt or something, okay. So I think so very easily you can design this, okay. So first you have to write the status, okay. So you can represent 0, 0. So this is 8-bit resolution. So so you have to use 8 bits, okay. Maybe you will not give an 8-bit the big one, okay. Yeah, maybe you are given. Yeah, maybe you are given 8-bit resolution, okay, but it is not much difficult, okay. So you can write all the available combination, okay. 0, 0, 0, 0, 0, then 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 1, 1. Likewise, you can write all the resolutions. Wait. Okay, I think so you will not get that kind of big one, okay? Because you have to write very big one, okay? So maybe you will have, I think we have already done 4-bit resolution, uh, 4-bit resolution ADC we have already designed, okay? So for the exam question also, you will get maybe uh, 3 or 5 bits resolution ADC, okay? 3, 5 or 6-bit resolution, okay? Not, you will not get 8, okay? So anyway, if it is, let's say that if it is 6-bit, okay? If it is 6-bit, you have to use 6-bit uh, for the output, okay, ADC output, okay? That means 6-bit will represent one voltage level, okay? So there are 2 to the power 6 levels, no? 2 to the power 6 levels are there, okay? So if it is 0 and 5 volt, between 0 and 5 volt, okay? So there are 2 to the power 6 one, okay? Then you have to find the minimum voltage, okay? You can represent using one sequence, okay? Then you can assign the voltage value for each and every combination, okay? So if there are 6 bits, okay? So there are 2 to the power 6, that means 64 voltage level and 64 combination, okay? You can have to write those voltage levels, okay? Then you can, you have to use the comparator, okay? Comparator means flip-flops, okay? Using the flip-flops, okay? I think you know the basic idea how we can design ADC using a flip-flop. Sorry, flip-flops, no, not flip-flops, op-amps, okay? These are op-amps, okay? So you can use op-amps to do this task, okay? So if you consider op-amps like this, okay? Like this, okay? So if you are given, so let's say that this is plus and this is minus, okay? V plus and V minus, okay? So if V plus minus V1 is plus value, for the ideal one, you will get this one, okay? So this will be VCC, okay? And if the V4 minus V1 is minus value, you will get this one, okay? So this is minus VCC, okay? So you can use this theory, you can use this property to use this op-amps as a comparator. Then using this kind of several comparators, you can design the ADC, okay? So we have to give the voltage values for the these voltage values for the each comparator, okay? You can use the resistor divider to give the voltage values, okay? Then you can design the circuit, okay? So I think we have done this one, okay? So no need to do is redo it, no? Okay. So this kind of design you will get, okay? So please refer my lecture if you can't remember, okay? And make the steps only, okay? Just mark the step only, then you can do your design, okay? So it will be maybe 6-bit, 3-bit, 5 bits or something, okay? Very some less bit, okay? Okay, so the ADC, so that is related with the ADC, analog to digital converter, okay? So maybe you have to know what is the use of ADC, okay? And when the resolution is high, what are the advantage and what are the disadvantage, okay? So that kind of things also you should know, okay? Then you can write the you can write the paper very well, okay? So the basically, okay, you will get the ADC design, okay? In addition to the design procedure, you should know the general information also. Okay, so you know need the knowledge of that signal and system stuff. Okay, how the frequency, sampling frequency, and the spectrum. Okay, so that kind of so we are not going to use that approach. Okay, we have done it. Okay, but it is just for our information. Okay, but we are not going to use that signal and system approach to design or analyze the ADC. Okay, so this electronic implementation part you will have to do. Okay, so you should know the things related with the implementation. Okay, so that is the ADC. Okay, and DAC also very easily. And one question you will get from DAC design, ADC design, and also DAC design. Okay, so Q2 has two parts actually, ADC design and DAC design. Okay, so DAC also you can very easily design actually. Okay, so it is actually this one, no, the chapter 2A. Okay, so this is the Q4. Okay, question 4. Okay, so 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 actually this is a digital analog convert. Okay, so I think I have explained how this kind of circuits is working. So very easily you have to use the voltage divider circuit. Okay, voltage divider circuit. So if you are given 0, 1, 1 means you are given voltage here. 0, 5. So let's say that if you are given 1, 0, 1, okay, that means you are given 5, 0 volt, 5 volt. This kind of, okay. Then you can find the output voltage value, okay, based on this 3 voltage, okay. So you will get 1 voltage value, okay. So the input is, let's say that 1, 1, 1, that means 5, 5, 5, okay. Okay, so so you can use this equation actually for this diagram. You can use this equation, okay. So you can easily find the corresponding uh, voltage value. Okay, so basically you will give this kind of circuits, okay, this kind of resistive ladder, okay, maybe this one, okay, and there are other implementation also, this one, okay, okay, this one, okay, I think only two, okay. So maybe you are given this kind of ladder circuit or this kind of ladder circuit, okay. Actually these ladder circuits are working very well, okay, uh, with the Arduino, okay, with the Arduino. I have tried this kind of ladder circuit with the Arduino for audio processing, so it is working very well. It was working very well, okay. So these are working very well, okay. uh, so maybe you are given this one or this one, okay. And if you are given this one, okay, so this is the this voltage value, no, this will be the voltage value, okay. So sometime you may ask to derive this one, okay, derive this expression, okay. So I'm not going to do the derivation, okay. So try to derive this, okay. Actually here the derivation is not there, okay, derivation is not there. I think I have done the derivation for this one and this one, as I can remember. This one or this one, okay. I have done the derivation for this one or this one, okay. So you can use the same procedure, okay. But when you are, if you are asked to derive the expression for this one, okay. So you have to care about this resistor, okay. Because so for this one, these resistors are all connected parallelly, okay. But here it is not parallelly, okay. So here you are using the intermediate resistor, okay. So when you are using the Kirchhoff law or Ohm's law, you have to care about this resistor, okay. So maybe you will ask to derive this equation, okay? So try to derive this. Actually, it is not relating with the digital, okay? So if I ask to derive this, it is not related with the digital electronics, okay? Digital electronics. Actually, it is analog electronic part, okay? If I ask you this derivation, it is analog electrical part, electric part, electronic part, okay? So, mm, so just try to derive it. Use 10 minutes or 15 minutes, try to derive this, okay? If you can't do this, you can skip it, okay? So you will not, but if someone try to derive, okay? But if I try to derive this, I will give some marks, okay? But it is not, so it will not much affect your final marks. It will be a few marks, okay? So try to, if you have time, try to derive. If I ask you to try to derive the expression, try to derive it, okay? But actually it is not with the digital electronics, so I am not, it may be not fair to ask that kind of questions, okay? Uh, so anyway, okay. So try to derive this if you have time, otherwise just leave it if you can't do this, okay? So you will not lose much marks, okay? But if someone try this, at least try get if someone got a try to solve this, I will give some marks, okay? Okay, so you will get this kind of DAC. Uh, uh, Maybe implementation or something, okay? So maybe you have to assign some voltage for 1 and 0. You have to assign, okay? Then you are, so this is if you are asking to, let's say that you are asking to make 5 bits deck, okay? So maybe, uh, so there can be combination, no? 2 to the power, 2 to the power 5 combination, 32 combination, 0, 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3, like that, okay? So you will have 32 combination. For 32 combination, you have to find the uh, respective voltage, okay? So easily you can use this equation, okay? You can use this equation for that one. Maybe this one, or maybe this one, okay? It is based on the implementation, okay? Maybe I am given, so there are other type of configurations are also there. Yeah, okay. So you please submit it to the LMS, okay? So use the, please, follow the normal procedure, okay? You can follow the normal procedure. So you have to update it to the LMS, okay? So I think this paper is not much difficult, okay? All the things I have done, okay? All the things related with the paper I have done. The all things are in the lecture, okay? So I haven't given anything um, out of this reference book or lectures, okay? All are within this reference book and lectures based on this reference book and my lectures, okay? So there will no any additional things, okay? So I think it will be very easy, okay? Okay, so I think now uh, you have an idea to do questions, okay? So I think you can do this one, okay? So I am not going to, so very easily you can use this one or this one, okay? This one or this equation and find this voltage value, okay? So that is the things you should do, maybe, okay? Uh, okay, so I think you can do the question exam, Okay. So I think this type of, actually this is not a tutorial session. Okay. So I am not doing any, I haven't done any question. Okay. So if you are going to do the question, so this 2 hour will go to do 1 or 2 question. Okay. That is why I am not going to do the question. Okay. So I will just give you a quick recap and general guidance. Okay. How to get, how to approach to solve these questions. Okay. This exam question. And so I think you can do this. Okay. So one thing, okay. So maybe you can remember that we have covered only 3 LOs, no? We have covered only 3 LOs, LOs 1, LO2, and LO4. Okay. We couldn't cover LO3. Okay. So LO3 is related with the programmable logic array. So I think this is very important. Okay. This is very important because nowadays we are not using this counter and flip-flops level design. Okay. So normally we are using this kind of programmable arrays for our design. Okay. So there are different logics levels we can use. Okay. So you can use the very basics. Okay. Transistor level design. Okay. Then you can use the logic level design. Okay. Then you can do flip-flops and flip-flops level design. Okay. Then you can do counters and registers level design. Okay. But we have done these things, all these things. Okay. Up to some level. Okay. And count and register level design and flip-flops level design. Actually, these are not covered in our syllabus. Okay. Flip-flops level and logic gate design, we are mostly focusing on counters and registers level design. Okay. So we have done that. Okay. But we have to give our first step for programmable logic arrays. Okay. So FPGA, for example, FPGA come under this one. Okay. So this one also very important. Okay. So actually, I want to do this. Okay. Otherwise our syllabus will not cover. Okay. But the end exam you will get only from these 3 LOs. That is why you have only 4 questions. Okay. But this one also we have to cover. Okay. So after the exam I will get additional 1 or 2. Maybe Dr. Kapila will do this part. Okay. Maybe Dr. Kapila, he is expert than me for this programmable logic array. Okay. So please join with that. Okay. Don't leave it. Okay. So maybe I will give you some very small activity also, but I am not going to take it for a continuous assessment. Okay. If you have all done, I can consider it. Okay. So, but I think this will be very important for you, maybe for your final year project. Okay. So don't forget this. Okay. So I will take some maybe 4 hours at least, 4 or 6 hours on this one. Okay. Actually, it should be 8 hours. I can remember. Okay. So maybe I will take the 8 hours. Okay. I can't remember. Maybe 6 or 8 hours. Okay. Wait. Okay. So I will take that time. Okay. Maximum 8 hours. Okay. That means maybe 4 hour 2 session or something. Okay. Yeah. You will have additional 30 minutes to upload the answers. Okay. The same procedure. Okay. 3 hours and 30 minutes. Okay. So you can use any software, any AI platform. I don't care. Okay. You can use them, but you can't chat. Okay. Don't open WhatsApp or any other social media. Okay. But you can use any website or software. You can use MATLAB. Okay. Maybe Proteus you can use. No issue. Okay. That is it. Okay. So for the counters also, if you can directly do it using the Proteus, okay, you can do it, okay. Mm, But I think you have to go through that design procedure. Otherwise, you can't do that one, okay. If you are good, if you are an expert, you can do maybe directly, okay. But I don't hope so. We can do. Okay, so shall we wind up the session? Do you have any question? So anyway, please go through the lectures and go through this guidance, okay? And if you have any problem, you can mail me or you can ask me. Okay, then I can explain. I will try, I can help you, okay? To clarify the issues, okay? So you can anytime mail me or call me, okay? Anytime is if you are giving me a call, please call me within the office time, okay? You can mail me anytime, okay? Then I can answer. I can give you, I can help you. Okay. So shall we wind up? Do you have any question? So anyway, I will wait here around maybe 5 minutes. Okay. So if you have any question, you can ask. Okay. Otherwise, you can leave.
Thank you, sir.
Okay. Thank you for participating.
Thank you, sir.
Okay. Thank you. Okay. So if you don't have any, yeah, I will upload. Okay. I will upload this session. Okay, thank you for participating. Okay, so I will.